Hi guys, and welcome to the next video. Today is going to be the last part of the data and position registers, and today I'm going to cover the position registers. So let's get to it. Alright, so we spoke about the data registers in the latest video. If you don't know what I'm talking about, check out the video right here. And today let's cover the position registers. So what is a position register? Basically, it's a matrix of registers. So we're going to have, you can imagine two columns. Actually, when you take a look at it from the robot perspective, it's just one column with X, Y, Z, W, P, R values in it. So basically, you're going to store your position data in that matrix. Why is it a matrix, guys? That's because you can access each element over there separately. So you can just modify or access the X position, or maybe just the Y position, or maybe just the rotation, or whatever you need. We're going to talk about it more when we get to vision, when we get to offsets, and so on and so on. Today we're going to talk about it, and I'm going to show you a simple example of a very easy palletizing program using what we've learned so far, and that's registers and position registers. I'm going to use a little bit of logic of the if statements. I'll explain it to you, but we're going to cover the if statements soon. Okay, what is important about the position registers and what is the main difference between a position and position register? I've mentioned that before. Just one more quick note. The positions are saved locally inside the program. The position registers are saved globally, and you can access it from anywhere in the robot. So you can access it directly in the data position register screen, and you can access them in any program wherever you want. The most important thing also, position registers, the position store user frame and user tool data. Position registers do not store them. Very, very important. I'm going to show you an example. What does it mean? Okay, so there will be a few things I'll be talking about during the exercise. First is going to be just the table of the data position registers. How do we operate there? What are the options that we can use? And the second part, I'm going to show you why is it so important to remember the tool frame and user frame that you used to save the position register, and how does it affect your program and what you can do with it. And the last part is going to be the palletizing program, and I'm going to talk a little bit about how you can make a very simple palletizing program and how you can actually copy it from what I've done and try it out yourself and play with the values to see how you can increase the number of the blocks that you're dropping or picking, depends what your application is. Very cool things, guys. So like always, without further ado, let's get to the exercises. Hi guys, and welcome to the exercise. So today we're going to take care about the position registers. So how do we get to the position registers? The same way as we did with the registers. We're going to hit data button, and you're going to get to position registers. If you are not at the position registers, most likely you need to hit type and then select option number 2, position register, hit enter, and they will open up. So there are two things that you can see in here. One is that the name of the register can be blank, and there can be an asterisk here. So if the name is blank, you can of course input the name in here. It says please press enter, so you're going to press the enter button and you're going to name it however you want. Let's name it position register. Okay, so we have that one. Now what the asterisks mean? The asterisks mean that the data in the position registers is not initialized. That means there is no values in there, just asterisks. So in the registers, let me open them on the other screen. You can see it's either 0 or 1, so there is always a value in. In position registers, there is not always a value inside. The asterisk doesn't mean there is a 0 inside. The asterisk means there is nothing in there. And the robot don't know what to do with that data. How to see what's inside the position registers? You're going to choose the position register that you want. You're going to hit position. And in here, you're going to see that there is nothing. Everything is an asterisk, meaning that the robot won't be able to tell you what's going on. Okay, you can hit done. Now, how does the initialized position look like? So, for example, let's take a look at this one. When you're going to hit the position, you can see that we have some values inside. And you know that you can use this position register in your program because that position has been taught earlier. All right. And that's about it from the basics. Right now, let's see how do we add the registers, the position registers to the program. How do we operate with them? How do we save them? How we move to the position registers? So I've made a program in here, PosReg, which is an empty program, and I'm going to show you the difference between the point and the position register. Like I said before, the points are accessed locally inside the program, and the position registers are accessed globally throughout all of the programs that you have. Okay, so let's zoom in a little bit and let's take a look here. So I'm going to add a point and I'm going to add the joint movement. In here, we have the point number 1. Okay, so what do we do? How do we change it to the position register, or how do we add a position register? Very easy, guys. You're going to go with your arrows to the point. Right now, you're going to hit choice and you're going to select position register and hit enter. Right now, you're going to use the position register number that you want to use. So let's check what do we have. The one that I saved was number 94. So we're going to put in here 9 and 4. We're going to hit enter and that's our position 94. Now, as you can see, I did not save that point yet. That's meaning if I will try to move to that point, let me add one more line so you can see that I'm actually moving. You're going to get this error, which is kind of common, and I'm sure you face it at least once during your career. So if I will try to run it, boom, uninitialized data. Let's take a look at the whole error. See, uninitialized data is used in the program in line number 3. So how do we handle this case? So there are 2 ways how you can touch up a position register. One, while you're in the program and making the movement, you can just do shift and touch up, boom, and position has been recorded to position register number 94. As you can see in here, it says that the position is recorded, and when you open the position in here, we open the position in here as well, they will match. Those are the same points. Okay, great. Okay, so how do I change it? Well, you can move the robot, and if you touch it up again, it's going to override the value in here and in here. Is there other way to save a position registers? Of course, there is. You can go to the position data register screen, and in here you see option record. So let me move the robot out of the way. Okay, so we're not at the point anymore. And in here, if we're going to hold the shift button, we need to hold the shift button. If we try to record without the shift, we're going to get press shift key to record. So we're going to hold the shift key and I'm going to hit record. Boom. Position has been recorded to position register number 94. And as you can see, we have the asterisk in here, meaning that the position in our program matches the position inside the position register. Great, great. Okay. How do you clear the position register? You have a clear button in here. Again, press shift to clear. So accidentally you cannot clear. You cannot use any of those buttons without the shift except for the position. You're going to hold shift button. You're going to hit clear. And it will ask you, hey, for sure Do you want to clear that position register? Yes, we want. Yes, we do. And what do we get? Asterisk. So data is uninitialized. Okay. What is the main difference though between the position registers and registers? In order to show it to you, I'm going to save a point and then I'm going to save the position register in the same point. So we're going to save this one and we're going to touch up this one. So those points are the same. If I run through the program, the robot is not going to move. It stays in one point. But let's take a look at this. So if we take a look at the position, let me open that program in a second window so we can see this nicely actually. So you can see the difference. Okay, what's the main difference in here, guys? Well, the main difference that you're going to see is that in here we have predefined user frame and user tool. But in position register, we do not have those. So what does it mean? For us, it means that the position register does not store user frame and user tool data. So you can move to this point, to those coordinates using any user frame and any user tool. So whenever you record a position register, you need to remember which user tool and user frame you've used. It is very, very important. Before I show you the example how this works and what do I mean by that, let me tell you one more thing that you need to remember. So of course you can move to the point within the program. So we can of course do shift forward and drive through the position register and you're going to get to the point. But probably as you've seen in the data position register screen, the point that we saved, number 94, that has a move to button. And the move to button is going to move the robot to the point. So if you hold shift key, I'm going to hit move to, the robot is going to move to the saved point. However, guys, like I said, before you move, you need to make sure that you have the correct tool and correct user selected that the position register was taught with. There is no way of knowing who saved it and how they save it, which tool they use or which user frame they use. So it's guys critical to know that you need to move to this point with the correct user frame and correct tool. What is going to happen if you don't know it? Let me show you. So we're in the point. Let's say, let's change user to number 1. Okay, so now we have tool 2, user 1. I did not move. The only thing I changed is the user tool. If I try to move to this point now, well, the robot is going somewhere else. Why? Exactly because what I've said, because he is trying to move to this point using the latest known user frame and user tool. So if I change back to the one that I taught, which was number 3, okay, and I will try to move to this point, the robot is actually going to move to the point that I want. That's why I'm saying, guys, you need to know which user frame, which user tool you've used in order to use the move to button. Is there a way around? Of course there is. If you want to make sure that somebody is going to always go to this point, you can hit position in here and change the representation of the point to a joint. This way, you're going to be sure that the point is saved correctly. Whenever you do this, you'll have a pop-up screen saying what is your active user frame, what is your active tool frame, and the robot is going to convert according to this. Because the one that we have active is actually the correct one, when I hit continue, I'm sure that that point is going to be, the coordinates are going to match because I saved that position register using those frames. And right now, regardless of the frame, we can choose number 5. If I try move to, the robot will not move. If I'll put 6, move to, it will not move because the position is saved as a joint representation. That's very important, guys. Okay, let me just change back to the Cartesian representation. Let me use the one that I actually have, number 3. Okay. All right, so we have our Cartesian representation. Okay, let's make sure that that's the correct point. And right now, guys, there is one more important thing about the move to button. So the move to button is going to use a linear movement, not a joint. It's going to execute a linear movement. It is very important because you need to remember when you are executing a linear movement, the robot doesn't care about the config. Also, the position registers, the robot doesn't care about the config if it's going to be a linear movement. So what I'm trying to say, let me show you. If in this position I'm going to rotate axis number, let's say 4, by 360 degrees. I don't know if I can though, but let's see how far I can turn. Nice. And I'm going to save this point like this. And if I try to move to the next position, what happened? Why the robot didn't move? Right? Remember? See, like I'm not at the point really. But if I try do move to, well, the robot finished the movement. Why? Well, you don't believe me? Okay, let me move the robot a little bit. Boom, I moved. Is it correct? That's how you save it? No, guys, because move to is executing a linear movement. That's why we're having trouble. Let's see what's going to happen if I will try to move to it using the joint. Boom. The robot rotated 360 degrees because if I'm executing a joint movement, I will take care about the configuration. That's the other topic I'll speak about this. When you're executing the linear movement, move to, he doesn't care about the configuration at all. Not a bit. So for him, the linear movement to this point, when the axis is like this or the way it was around, he will not care. It's very, very important, guys. I wanted to mention it. Remember that the move to button can cause you some trouble because you will think you are at the point, but you won't be at the point. As you've seen, you won't see the asterisk symbol if you move to, but you are not at the point. Okay, so let's go a little bit further then. The thing I told you that the position registers, they do not hold the frame data. Is it good or bad? Well, that depends. I'm not a big fan of position registers, but they are very powerful, same as registers in FANUC. Let me show you an easy example when this can be very useful. So as you can see in here, we have two tables. So I did teach a tool frame for both of them. So tool frame is more or less located like the zero of the table, just it's at this height for both of those tables. So the 0 for me is in here and the 0 for this table is in here. And let me show you why is it so important to remember your frames. So for this table, I have user frame number 1. For this table, I have user frame number 3. Just so you can see. See, that's my 0 point right here for the frame. And let's take a look at this. So I'm having 4 points in here. Point 0, 0, 0, point minus 1200, point minus 1200, 600, point 600, and then I'm going back to my first point. So basically I am going to make a movement like this around the table because it all referred to the frame of this table, correct? Okay, so we have our user number 1, which is this table, tool number 2, which is the tool that we're carrying. Let's move to the first point. Okay, dokie. So we are at the first point, right? Okay, let's move to the second point. So we just follow the table. We're going to move to the first point. We're going to move to the fourth point, or the third, depends how you look. And then we're going to move back at the beginning, and our round is complete. Now, as you can see, those two tables are exactly the same. So the frame methods are also exactly the same. So what is going to happen when I'm going to switch a frame to frame number 3? As you can see, frame number 3 has the 0 in here, but it is the same table. So I did not change the program, and I'm going to move now to point number 1. As you can see, I didn't make any changes. The only thing I changed is the frame. I'm at the beginning of the table. So for the robot, from the robot perspective, I'm in this point. This point and this point is the same. It's the point 0, 0, 0. Now when I move, I'm moving exactly the same. I'm following the same path. I'm going here. I'm going to move forward. I'm going to move back. I move back, so I move to this point, and I'm going to move back to the 0. Boom. So as you can see, that's why the position registers are also very, very powerful, because I gave you just an example with two tables, but imagine that you have a rack, for example, with like many parts that you stack, and then you can use a different frame for different rack position. And then you just touch up one point, and the rest is going to match because you have correct frame. And that's why also you need to remember which frame you're using while using the position registers. It is, guys, very, very, very important. Okay. In the end, I wanted to show you a quick example of the palletizing program that I made here. Palletizing can be done in many, many ways. I just tried to use whatever we know so far, except for jump labels and if, which are necessary in order to make it run. But I tried to make it as simple as possible. So let's see how I've done. And again, palletizing can be done in many, many ways. It can be done differently. Again, I was trying to use what we know. So there are a few things that I want to show you. First one is like a initialization, where we're going to reset all of our data. What does this line do? Basically, I have a point that I saved as point number 99. This is the first point that I pick, which is going to be this block in here, right here. And what does it do? I'm going to copy the value from this position register and paste it in here. There is one function that you didn't see yet, and it's this one. Basically, it says position 100, comma 3. Comma 3 means, when you take a look at the position, the third column. So this is the first column, the second column, the third column, fourth, fifth, and the sixth. So this is how you operate on the position registers if you want to change just one value, just X, Y, or Z, or the rotation, of course. And that's what you're going to use in your palletizing programs. So you want to change only the X, only Y, or only Z, depending on what you need. So as you can see, I've made a program where I'm offsetting my values. I'll go through line by line so you can understand. My X value and my Z value, because I'm going to pick this one, then go up, pick this one, and pick the I'll drop actually the last one. I will be picking from here. Okay, so let's see how it works. So first of all, I'm going to start the program. I'm going to set my user frame and user tool, very important. Then I'm going to initialize all of the data. So basically I'm going to zero everything out because I don't want to do anything. Why I have a jump label 10 in here? This is because in this I'm lifting the current position in Z by 150 millimeters. So I want to do it right now. I want to start from the beginning. So first thing, we're going to go to the peak position. When we are in the peak position, we'll pick this part, we'll continue. We're going to move above the drop position. Okay, now we're above the drop position. What's going to happen now? Right now I'm going to say, okay, place number. I'm going to place element number 1. So I'm going to add 1 to my register. I'm going to move to the place. So I'm moving to place the first block. Okay, I got it. I'm going to move back to my position number 2, which was above the drop. Now what I'm going to do, I'm going to subtract a value of 200 because the distance between those two blocks is 200 millimeters. And now, because I already placed one block, right now I want to move to the other one, so I need to jump through the program again. So this line is just going to jump to the beginning of the program, and we continue. So we're going to pick again. We're going to move above our drop. We're going to add one more value because right now we're putting the second block. We're going to move to place. We're going to place it because we've subtracted the 200. We're going to move back up. And our first line is complete. Of course, if you want to add more blocks, just simply change this value in here to be greater than 1. And because you want to place more blocks, put it 5, then you're going to place 4 blocks and you're going to move to the next line. But I have just 2 in this example, so let's continue. Okay, so right now I'm going to subtract 200 one more. That means my next position should be here, but because I already passed my 2 blocks I wanted to place and the value is no longer smaller than 1, I'm going to continue. This line is basically going to say if my position, if the value in X in my place is smaller than this value, then just copy it from the base position. So basically, because I already know that I moved by 200, that means I'm going to set my value back to 0, so the robot would normally move here. So I'm resetting basically my data position. And right now I'm going to jump to label 30. That was the one at the beginning. So what does this label do? Basically, I'm adding right now a value on 150 to my current position in the position register. So basically, I'm going to move here. So we run through this line. We're going to pick again. We're going to move above the drop. We're going to say that we're placing the next drop, so we're going to add 1. I'm going to move to place, and I'm placing it on the top nicely. Move back. Let's go through our logic. So I'm going to subtract 200, so I make sure I move to here. I'm not going to jump to this because it's more than 1. I'm not going to execute this logic yet because the value that I have is not smaller than this one. I'm not any farther because I just go through the logic just one time. And now it's my first block, so I don't want to add to the Z anymore, and only thing I did was the change in X. So let's continue. Let's add one more. Let's place it. Let's go up. Let's subtract 200, so next one will be here. And guys, I'm going to finish my palletizing program. This very simple example. You can play with it. Just remember, whenever you want to play with it, you gotta change a few things. You want to change this one. You want to change this value, and those two. So if you want to add more blocks here, you need to remember, I'm sorry, this one you will not change. Remember that you need to change this to 400, 600 and so on, depending how many blocks you want to put. This is the first change that you need to make. The second change is you need to remember, so basically you can imagine this is like 2200 subtract by 1, so you will get 200 in here. If you're going to put 5, it's going to be 200 times 5, so you're going to put 1000 in here. That means you can put 1, 2, 3, 4, 5 blocks in here, and then 5 blocks at the top. And well, not that fast, and you will need to change this number for the top one. Then so you need to change this, and then you need to change this one to 5 in order to pass the 5 blocks at the top. If you want to change the height more, then you need to change this number to, for example, 3, and then you should be able to put more blocks in here. Play with it, guys. Play with it. You have a ready solution now. Like I'm saying, it is not the fastest, not the easiest solution, because we're limited with our knowledge. But just with this, you're able to make a simple palletizing program. Okay, guys, that's all from the exercises. Thank you. Alright, guys, I hope you enjoyed the exercise. Like always, please don't forget to like, subscribe, leave your comments down below, and guys, see you in the next video. Bye bye.